Hi everyone, this is a second combination of capacitor analysis video. Please watch the first one, combination of capacitors 1, first because you're going to see the same circuit but set up a little differently. In the previous circuit, we had a 32 microfarad and 58 microfarad capacitor in series with each other, and then in parallel with a 76 microfarad capacitor. Here I've done the reverse. I've put the 76 microfarad capacitor in series with a parallel branch containing a 32 and a 58. So what I want to do is analyze this circuit to show you the differences in the two and how we go about it. All right, the first thing that I want to do is I want to take this parallel branch and I want to combine it. The way we combine capacitors in parallel is we do the direct sum. So that would be 32 microfarads plus 58 microfarads, or 90 microfarads. So now I can redraw my circuit to look like this. Where I still have my 4.5 volt battery. I have my 76 microfarad capacitor and my 90 microfarad capacitor. And now I can get my equivalent capacitance by adding the two together. However, because they are in series with each other, I have to do the inverse sum. Or 1 over 76 plus 1 over 90. And I'm going to hit that into my calculator right now. 1 over 76 plus 1 over 90 equals. That gives me that 1 over my equivalent capacitance is 0.0243. But I have to remember that that is 1 over. So my equivalent capacitance is going to be the reciprocal of that, which is 41.2 microfarads. Okay, why don't you pause this, go back, solve it yourself, and come back when you're ready. Okay, now that we know what the equivalent capacitance is, now we can take and analyze each capacitor. The first thing that I want to do is I want to find the charge and voltage on the 76 microfarad capacitor. Then I'll do the same thing for the 90. Now, what makes this a little easier is knowing that the charge Q not only is equal to C times V, but that charge is going to be the same on both because these are capacitors in series with each other. So that would be my equivalent capacitance, 41.2 times 10 to the negative 6 farads, times the voltage of my battery. That gives me 1.85 times 10 to the negative 4th coulombs. And that is the charge on both the 76 and the 90 because they are in series. And Q is constant. So if I make up a little table for myself, I can say Q 76, V 76, Q 90, V 90. I can fill in 1.85 times 10 to the negative fourth for both of the charges. Now that I know the charges, I can find the voltage. I'm going to use my same formula and say V now equals Q over C. So my 1.85 times 10 to the negative fourth divided by the capacitance of the individual capacitor. So 1.85 to the negative fourth divided by 76 to the negative sixth. That gives me 2.43 volts. I can now do the same thing for the 90. That charge (1.85 to the negative fourth divided by 90 to the negative sixth). That gives me 2.06 volts. And now I'm going to do a little check, what I like to call my little fail-safe. In series, my voltage should add up to the voltage of my battery. So let's add these up. 2.43 plus 2.06 gives me 4.49 volts, which is approximately 4.5, which is what my battery is. So I know that I did that right. Okay, why don't you take another pause, go back, review, and then come back when you're ready. Okay, so now that we know the charge and voltage on our 90 microfarad capacitor, I'm going to remember that that 90 microfarad capacitor really is a 32 microfarad and a 58 microfarad capacitor in parallel. And in parallel, voltage is constant. So I can say Q on the 32, V on the 32 is 2.06 volts. Q on the 58, V on the 58, also 2.06. And then I'm going to use the same formula that I used back up here. I'm going to use this formula to find the charge on those two capacitors. Okay, so Q is C times V. So that's going to be 32 times 10 to the negative 6 farads times 2.06 volts. And then I'll do 58 times 10 to the negative 6 farads times 2.06 volts. All right, so let's plug those in. 32 to the negative 6th times 2.06. That gives me 6.59 times 10 to the negative 5th coulombs, and 58 to the negative 6th times 2.06 gives me 1.19 times 10 to the negative 4th coulombs. Okay? Now, just as last time, we had this little fail-safe to check if we were correct. We've got another built-in one right here. We had said that the charge on that 90 was 1.85 to the negative 4th. Well, if I add these two up, I should get 1.85 times 10 to the negative 4th. So let's check and see. 1.19 times 10 to the negative 4th plus 6.59 to the negative 5th gives me 1.85 times 10 to the negative 4th, which is exactly what I got there. So we have analyzed this new circuit to find both the charge and the voltage. Now I could do one other thing. I'm not really asked for it a lot, but I could find my energy. Energy is going to be 1/2 Q times V. I could find that other ways as well. So I could take any of these that I want and put it into that formula, and then I would get the energy that's stored in the capacitor as well. Okay? So if you haven't already watched the first video in the series, please go and do that so you can compare having a parallel branch first to having a series branch first. Okay? Hope you enjoyed the video. Let me know if you have any questions.